3, and switch 3 has a connection over here, and here is switch 4. Okay? Right here, we've created a third segment. This is segment 3. The rule says there can be one designated port per segment. So, on segment 3, notice, in order to get BIPIDUs from the root bridge, the path that would have to be taken would be out of the root bridge, coming this direction, up through switch 3, coming out of this port right here. In order for segment 3 to receive BIPIDUs from the root bridge, this port has to be active. So this is considered a designated port right here for segment 3. On switch 3, this port right here would be considered a, that's right, you guessed it, the root port. This is the root port because this is switch 3's connection to the root bridge. Over here, switch 4 has this port right here, which is its connection back to, or its path back to the root bridge. So therefore, this port right here would be a root port. If we added another segment out here, this segment right here, this would be a designated port for this segment, DP, and this would be switch 5, and this would be the root port for that switch. So those are our 3 basic rules for spanning tree. Number 1, there can be one root bridge per network. Number 2, there's one root port per non-root bridge. Number 3, there's one designated port per segment. Now the question is, how do we select which port would be designated, which port would be root ports, which ports are we actually going to block? This is done with what we call cost. The concept of cost is associated directly with bandwidth. And you'll notice that throughout the rest of this course. You'll see that not only with spanning tree, but also with OSPF. And if you go on further to other levels of Cisco routing protocols, you'll see it with other routing protocols as well. The concept of cost is associated with bandwidth. So here, we'll just say, for example, that segment 1 has a bandwidth of 100 megabits per second. That's a fast Ethernet link. Over here, segment 2 is a regular Ethernet link, a 10 megabits per second link. The fastest path to the root bridge is going to be the one with the lower cost. So the faster the path, the lower the cost. So in this particular example, segment 1 would be a faster path from switch 2 to the root bridge, and segment 2 would be the slower path. So therefore, the cost of this path would be lower. The cost here would be 19. And then the cost, of course, here would be 100. So the cost here would be lower, and so therefore, this would be chosen as the root port, and this port right here would be placed in blocking, which is referred to as a non-designated port. Spanning tree transitions each port through several different states: blocking, listening, learning, and forwarding. Let's take a look at each one of these states. You'll recall that we indicated before that this port would be put in blocking state due to the fact that this would be a higher cost path, this 10 megabit per second path and this 100 meg path right here. This being the root bridge over here. This port is placed in blocking state. If this root bridge right here goes down, the root bridge will no longer be sending those BIPIDUs. Now, by the way, those BIPIDUs contain information from the root bridge indicating information like the root bridge's ID, the priority, and other information relevant to spanning tree. If this switch 1 goes down, then those bipidues are no longer being sent or received by switch 2 on this particular port. Even though this port was in blocking state, it still is able to receive bipidues, by the way.